Welcome to Python Pandas Part 1. The modules which we'll be covering in this video is Basics of Pandas, Advantages of Pandas, NumPy array, in which we'll be discussing about the one-dimensional, two-dimensional arrays and its functionalities. And last, we'll be seeing the contrast between NumPy and list. Now, what is Pandas? So Pandas is the Python library for data analysis. Now, why do we require data analysis? Data analysis is required to analyze larger sets of data to get answer on questions related to that data set. Python module makes data science easy and effective. It has derived its name from panel data systems, that is multi-dimensional structured data sets. So we have large amount of data, and when it gets structured, it is termed as pandas. It is an open source software, and to work with pandas in Python, we need to import pandas. So we need to write this line in your any of the IDE of panda, that is import pandas as PD. So we need to keep in mind it is panda s. Okay, so pandas as PD. Now, what are the advantages of pandas? There are many advantages of pandas. So I have listed few of them. So let's go and have a look. It can read and write in many different formats, like every kind of data type is permissible in this format. Can do calculation in all the ways like horizontally, vertically, column wise, row wise. Can combine data sets and selects the subset of data. So it can combine one or more data sets together, and it can also bifurcate the subsets from that data. It can fill and find the missing data, and it can also replace the missing data with the values the user or the programmer wants. It allows to apply operations to the group present in the data set. So we have different data sets. It allows the binary operation and other operation like Boolean reductions and other things on its data sets. Supports different libraries for visualization. So when we are talking about data analysis, visualization is the important point. So it supports many different libraries as plugin for visualization of data. NumPy array. So this is the array as one of the data structures in pandas, that is NumPy. It can create one-dimensional arrays as well as two-dimensional arrays. It is just like simple arrays which we do in every programming language. Now I'll just give you an overview what is an array. So array is a named group of homogeneous elements. Like if we want to store marks of different students, we can take an array called marks, and it has different locations starting from 0 to n, and you can store marks in that. Now NumPy is an open source module of Python that offers function for fast mathematical calculation on arrays and matrices. And to use NumPy, we need to again import NumPy as NP. Now this can be any name because this is a variable name, but we often take NP for NumPy and for pandas PD because that is the universal, renowned name for it. You can also change these names if you want. NumPy array is 1D array. So we'll see how to create single dimensional array using NumPy. So 1D array is also known as vectors, which has single row or column, single column only. Now we'll first create the list. List 1 as 1, 2, 3, 4, 5. And then we'll take a different variable n1 and we will transform that list into the array, and for doing that we need to write np.array list1. Now if we print n1, so n1 is a NumPy 1D array. When we print this, we get this number. We can also do it via directly giving the list as the argument for np.array. So we are not assigning this value to list1, we are directly giving this value as the argument, and then we can again get the print this way. Now here what we do is, here we are seeing that if we want to access the element, like we want to access the third element, we need to write n to 2. Why? Because the counting starts from 0. So the third element will always be the element at the second index. So, and if you want to do it for the first, we'll write 0. If you want to do it for the fourth, we'll write 3, that is n minus 1. Whatever element we want to print, we need to minus 1 from that. NumPy array, we'll see how to create a 2D NumPy array. So here we'll be seeing it. We have created 2 rows. First is 1, 2, 3 and the second one is 4, 5, 6. In the given list inside the list, and then this can be transformed to NP array. We have taken 2 lists and then we have combined it with comma, or we can take a single list, a nested list inside it, and then passed it as an argument to NP array. So there are 3 ways to create it. Now how to access the elements, single elements if we want. So the value of this element will be 0, 0, 0, 1, 0, 2, 1, 0, 1, 1 and 1, 2. So if I write 1, 1, the value is this. So we are getting 5. Now if we want to print n3, 0. So n3, 0 is all this 0th row. So 1, 2, 3, 1, 2, 3 has been printed. And if I write 0, 0, so this is 0, 0, so this is printed. It can have multiple dimensions. It has basically 2D has rows and columns. Now we'll be seeing the functionalities. So there are different functionalities. The very first functionality is type. The type of object. So here we'll see that L1 is the list and we have passed list as NP array argument. Now this list has been converted to NumPy ND array. So if I write type n3, we get the answer as NumPy ND array because this is the type of object n3 is. Now if I write n3.shape, so shape gives you the dimensions. So we can see here we have 2 rows and 3 columns. So here the shape gives you 2, 3. If we look about the item size, so it will just check what is the size of the item. So the size of the item is 4 and the data type is int 32. Now we'll be seeing what is the difference, or you can say what are the similarities and dissimilarities between NumPy array and Python list, because in the earlier slides we have just seen that we are creating the list and then passing it as an argument in NumPy array. So we'll just see what is the difference, why are we doing it so. Now similarity is you cannot change the size once it is created. So both NumPy array and Python list cannot change the size once they are created. And the second similarity is that they contain the element of homogeneous type. So if the data type is integer, so all the elements will be integer. If you try to give some float or the string value, it will give you error. Now what are the dissimilarities? NumPy occupies, or ND array occupies lesser space than Python list in terms of memory. NumPy supports vectorization operation. What do you mean by vectorization operation? That any operation is performed, it will be performed on every element of the array. Like if I write +2, then it will be added to every element. In the example, just like import NumPy as NP. List 1 is 1, 2, 3, 4, 5. I have transformed it to ND array. And after that I have added 2 to it. So the list value was 1, 2, 3, 4, 5. I have added 2, means every element is added with 2. So here we are having 3, 4, 5, 6, 7 as the result. But if we are creating a list and when we are writing print list 1 plus 2, it gives you error. that it can only concatenate two lists, and two value is the integer, it is not a type of list. So this gives you error. So this is vectorization actually. We'll just see that what are the data types which are permissible in your pandas. So boolean, integer, these are identical to cint, and this is for indexing, and different types of int which has different memory contained in it. Then you have float, complex, and other data types. So that's all with this video. If you like it, please press the bell icon and thumbs up. Thank you.